Section 10.3 on ellipses. So an ellipse is the set of all points x, y in a plane, the sum of whose distances from two distinct points, foci, is constant. So in these pictures, you see the ellipse is the oval-shaped image, and we have vertices are the 4 points on the ellipse. The major axis is the longer axis going in whatever direction. In these pictures, the major axis is left and right, and then minor axis is shorter, which is up and down. Then we have these focus points that help create the ellipse. The focus points are always C spaces away from the center of the ellipse. To find out how far away C is, we're going to use a squared and b squared from our equation. So when we do an example in a second, I'll show you how to find the distance to the focus. So in these next two pictures, we have the equations of an ellipse. X minus h all squared over a squared plus y minus k squared over b squared equals 1. The difference between the two pictures is in the first picture, a horizontal ellipse, the axis is longer left and right. So that's the a squared underneath makes it longer. The second picture, a vertical ellipse, is when the major axis is up and down, and so the longer amount is underneath the y squared, so that's still a squared in this picture. And like I said a while ago, the distance to the focus points is c spaces from the center, and we get a squared and b squared from the bottoms of the equations. So first example wants us to identify the center and radius of the circle. So a circle is just a special ellipse in which the distance in all four directions is the same. So the first thing we're going to do to this equation is get it to equal 1. So we're going to divide by the constant on the right hand side. So this will give me x minus 3 all squared over 16 plus y plus 2 squared over 16 equals 1. So the first thing to identify is the center of the circle or the ellipse, and that is HK in the equation. So we're going to take those numbers out of the parenthesis, and we always change the sign when we pull them out. So our center is located at 3, negative 2. So I put a point at 3, negative 2, and then I will find my radius, which is the square root of the number on the bottom of the fraction, and the square root of 16 is 4. So when I plot my center, I will go 4 in all directions and then connect the dots to create my circle. So again, a circle is just a special ellipse in which the distance in all directions is the same. Example 2. This one is an ellipse. Notice the numbers on the bottom of the fraction are different. So since it is an ellipse, we're going to find the center, the vertices, the focus points, which is foci or foci, the length of the major and minor axis, and we're going to graph it. So we're going to start with the center at negative 2, 2. Then I look at the number underneath the x, and I take the square root of that number. So the square root of 9 is 3. So I'm going to go 3 spaces left and right. I went left and right because that number was underneath the x. Then I take the square root of the number underneath the y, and I'll go that many spaces up and down. So I'm going to go 5 spaces up and down. Once I have the 4 vertices plotted on my graph, I can connect the dots to make my ellipse. Then I can write down the coordinates for the vertices. So my 4 vertices are at 1, 2, negative 5, 2, negative 2, 7, and 2, negative 3. I'm sorry, negative 2, negative 3. Next, we want to find where the focus points are. So we take c squared and set it equal to a squared minus b squared. So that's 25 minus 9. So c squared will be equal to 16, and c equals 4. C tells me the distance from the center to the focus points on the major axis. So since this ellipse is longer up and down, I'll go 4 spaces up and down for the focus points. Once I have those graphed, then I can write down their coordinates. So the focus points are at -2, 6, and -2, -2. Then I find the length of the major and minor axis, and this is just as simple as counting. So for the major axis, it's 10 spaces long, and the minor axis is 6 spaces long. Okay, number 3 wants us to identify as a circle or an ellipse and graph. This equation is not in standard form, so we need to get it in standard form. To do that, we're going to start by putting the x's together, the y's together, and then putting the constant on the other side. So I would write 3x squared plus 18x plus y squared minus 2y equals 8. Well, if you remember looking at the standard form of a circle or an ellipse, it has that perfect square on the top, x minus h all squared and then y minus k all squared. So in order to get that perfect square, I need a perfect square trinomial. So we're going to be completing the square with these again, same as we did with parabolas. First thing I do is look at the x terms and see if there's a number that I can factor out to get that x squared by itself. So I can factor a 3 out. When I do, I'll be left with x squared plus 6x. Now I'm going to go ahead and leave a space so that I can come back in a minute and complete the square. Then I look at the y's and see if there's a number I can factor out of the y's. Well, there's not, but I can go ahead and put a plus 1 if I want to. So plus 1, y squared minus 2y, leave a space, equals 8. So we're going to complete the square. So this means that we are turning what's already here into a perfect square trinomial so that I can write it as a perfect square in a minute. So to complete the square, you take the number that is next to the x, the 6 in this case, divide by 2, and you always square it. Always divide by 2 and square that number. So 6 divided by 2 squared is 9. So remember, whatever you add to one side of an equation, you have to add to the other side of the equation to balance it out. Well, I didn't just add a 9 to this side of the equation. If I distributed that 3 in parentheses, then there would be a 27 there. So I need to add a 27 to the other side. Same thing for the y's. I'm going to take what's in front of the y, -2, divided by 2, and square it. So this will be -1 squared, which is +1. Now this time 1 times 1 is still 1, so I just added a 1 to this part of the equation. So now I can write that perfect square trinomial as a perfect square that's factored. So it's going to be 3 times something all squared. Well, it's going to be x plus 3 all squared. X plus 3 times x plus 3, if I multiplied it out, would equal x squared plus 6x plus 9. Okay, for the y's, plus 1 times something all squared. This time it would be y minus 1 all squared. Y minus 1 times y minus 1 would be y squared minus 2y plus 1. Equals, on the other side, that would all add to 36. So you see how it's starting to look more and more like that standard equation. So we always need it to equal 1 on the right-hand side, so I'm going to divide everything by 36. And then simplify. So 3 over 36 reduces to 1 over 12. But I'm going to put x plus 3 all squared over 12. Plus y minus 1 all squared over 36 equals 1. So you can see that this is the equation of an ellipse because I have different numbers in the denominators of the fraction. So now that I know that it's an ellipse, I can use the pieces of information to graph. So we're going to start with our center at -3, 1. Then I take the square root of the number below the x, and I'm going to go that many spaces left and right. Well, the square root of 12 simplifies to 2 square root of 3, and that's approximately 3.46. So I'm going to go about 3.5 spaces in both directions. Then when I take the square root of 36, that's 6, so I go 6 spaces up and down. Then I can draw my ellipse. So now I need to find the distance to the focus, I need the vertices, and then the length of the major and minor axis. So the vertices are the 4 points that are on the ellipse. So since I went 2 square root of 3 spaces left and right, I'm adding 2 square root of 3 to the center of my ellipse. So that's why I have negative 3 plus 2 square root of 3, comma 1. And then negative 3 minus 2 square root of 3, comma 1. If this was a whole number, then I just would have added or subtracted that to the negative 3. But since it's a simplified radical, I can't add those together. The up and down points are easy. Negative 3, 7, negative 3, negative 5. Okay, now for the focus points. So c squared equals 36 minus 12. C squared equals 24, so then C equals the square root of 24. The square root of 24 simplifies to 2 square root 6, which is approximately 4.9. So I would go about 5 spaces up and down from the center, and it's on the major axis since it's longer up and down. And these are my focus points. So since I went up and down from the center, then I'm going to add 2 square root of 6 to the y coordinate of the center. So my focus points will be negative 3, comma 1 plus 2 square root 6, negative 3, comma 1 minus 2 square root 6. Now for the major and minor axis. So for the major axis, that's a whole number. So we went 6 spaces in both directions. So that was 6 times 2, which will make the major axis 12. The minor axis, we went 2 square root of 3 in both directions. So 2 square root of 3 times 2 will be 4 square root of 3. Okay, same thing as number 4. We're going to identify as a circle or an ellipse and graph. So we need to get this in standard form. So we would group the x's, group the y's, and move the constant to the other side. So for this equation, we just need to move the 625 to the right. Then I will divide everything by 625. 25 goes into 625 25 times. So this is x squared over 25 plus y squared over 25 equals 1. So this is a circle since the numbers on the denominator are the same. So to graph this circle, I'm going to start with the center. Notice there's not any numbers on top with x squared and y squared, so that's an understood 0. So our center is 0, 0. Our radius is the square root of the number in the denominator, so the square root of 25 is 5. So I would start at 0, 0. I would go 5 in all 4 directions, and then connect the dots for my circle. Okay, number 5 wants us to write the equation of the circle given the center and a point on the circle. So the center is HK, and a point on the circle would represent an XY. The equation of a circle is x minus h squared plus y minus k squared equals r squared. So I'm going to plug in HK and XY and solve for the radius of the circle. So this will be 4 minus 2 squared plus negative 3 minus 1 squared equals r squared. So 2 squared plus negative 4 squared equals r squared, which will give me 4 plus 16. So r squared equals 20, and r will equal the square root of 20. Well, now that I know my radius and my center, I can plug back into the equation of the circle. So x minus 2 squared plus y minus 1 squared equals the square root of 20 squared. So the only thing I need to change here is if I had any double negatives, I would change them to positives. And then on the right-hand side, squaring a square root will cancel that out. So x minus 2 squared plus y minus 1 squared equals 20 is the equation for this circle. Okay, number 6 wants us to write the equation of the ellipse. It gives us the endpoints of the major axis and endpoints of the minor axis. So in a sense, it's given us 4 points on the ellipse. I need to find the center, how far left and right this ellipse goes, and how far up and down this ellipse goes. So I would just sketch a picture and plot these points. You could also do it algebraically, and I'll talk about that as we go through. So if I graph these points along the major axis and the minor axis, here are my 4 points. The center of the ellipse is going to be the intersection of these 2 points, or it could also be the midpoint of either of the axes. So you could find the midpoint of either of these, and that would also give you the center. Well, if I just kind of connect the dots here, I can see that the center of my ellipse is at -4, 2. I can also see how long my major and minor axis is. So the major axis is 10 units and the minor axis is 4 units. I could also find this number by finding the distance between these endpoints. So now I can plug into the equation for an ellipse. So x minus a -4 all squared plus y minus 2 all squared. Now on the bottom, I take the distance the length of my axis, and since it's shorter left and right, that's the minor axis, and I take 4 divided by 2 and I'll square that. Same for the major axis. On the bottom, I'll put 10 divided by 2 squared and then set it equal to 1. So this becomes x plus 4 squared over 4 plus y minus 2 squared over 25 equals 1. So this would be the equation of my ellipse.